A ray of light is shone into, this is June 07, sorry, paper 1. A ray of light is shone into a rectangular glass block as shown below. The critical angle for glass is 41 degrees. Explain what this means. So what this means is that the 41 degrees is the angle of incidence for light travelling from glass to air which gives an angle of refraction of 90 degrees. The path of the ray through the glass allows it to strike the shorter side. The angle of incidence for this ray as it meets the shorter side is 50 degrees. Complete the diagram to show the path of the ray through and out of the glass block. So if we, first of all, of course, every time light hits the surface we draw in a little normal and put it in there. And because it's going into the glass, it's bent towards the normal. So we'll give it an angle here. Say something like that. Now it says the angle of incidence for this ray as it meets the short side. So the short side is BC there. And it's 50 degrees. So if we draw in a normal here, then it's that angle there that they're talking about, it's 50. Now really what they're trying to say is, right, you should have an idea that, or you do know that the critical angle of glass is 41 degrees, but this angle is hitting the side at an angle more than 41. So in other words, it is totally internally reflected there. And so we have to have it reflecting at an angle of approximately 50 degrees. And again, you should use a protractor, and so should I, but I haven't got one to hand here. And so if it does that, if it reflects at an angle of approximately 50 degrees, then it's going to hit side BC. And whenever it hits BC, there's the direction it should go. Whenever the angle is going to be much less there, it's only going to be 40 degrees. And whenever it hits BC, it is of course refracted away from the normal on the way out. And so there's, if I put that on this side actually, there's the angle between the normal and the ray at the minute, but it's refracted away, so this angle becomes bigger. So it moves in this direction here. So you would get 1 mark for showing that this is bent in the correct direction, 1 mark for your total internal reflection and your angles more or less equal, and 1 mark for showing that it's reflected away from the normal on the way out. What happens to the speed of light when the ray passes from air into glass at the side AB? And you can see it's bent towards the normal, so therefore it slows down. Explain why the light follows the path you've drawn at the side BC. So you can explain that the angle of incidence is greater than the critical angle. For glass. And so it is totally, I'm going to just write totally internally reflected. What happens to the speed of light when the ray passes from the glass into the air at side CD? So you can see that just at the top of your screen there, and you can see it's bending away from the normal, so that means it speeds up. Part B, so we've now got a lens question. A converging or convex lens can be used as a magnifying glass. The object O is placed at the position shown in the diagram. What is the name for the points marked F? And the point marked F is called the focal point. On the diagram, using a ruler, draw rays that can be used to locate the position of the image. Make sure you put arrows in your rays to show their direction. Your drawing should also distinguish between lines that represent lines of light and lines that you use to locate the image. The image should be clearly marked so that its size is clear. Now, they're saying lines you use to locate the image. If you can see here, the object's between the focal point on the left hand side here and the centre of the mirror, or sorry, the centre of the lens. So therefore, we're going to have a virtual image, and that's why they're saying about the rays of light being, or the lines locating the image are going to be different. So we'll start off drawing our normal rays, and the first one we'll draw is down through the centre of the lens and through the top of the image. Sorry, the object, I mean. It does, of course, when you extend those rays of light, it does go through the top of the image. There's your first ray of light, and then the second ray of light, we draw a line parallel, or a ray parallel to the axis, and then down through the focal point on the other side there, which is about there. So there's the ray there, and you're going to have lines extending like that there. We're going to put arrows on the rays coming from the object, like that. And we're also going to mark the position of the image, and that's where the two lines cross out here, and it's approximately there. So there's where the image is there, and we call it I down at the axis here. So just check what we've got in here. We have rays to locate the position of the image. We've got arrows in our rays. We've got lines which are different here between the ray, or they're different from the rays. These are lines which are going to help us locate the image, and the image is clearly marked so that its size is clear. So we generally draw an arrow. If the rays have come through the top of the object, if there's a ray come through the top of the object, it comes through the top of the image. So therefore this image is also upright. The arrow is at the top of this image as well, and that clearly shows the size of our image. So to get your 6 marks, you'll get a mark for this correct ray. You'll get a mark for this one correctly. You'll get a mark for the 2 rays extended. You'll get a mark for your image. And you'll get a mark for your arrows. And you'll also get a mark for the lines being different. And there's your 6 marks. So it's really worthwhile being able to do that, and this is a very common one to come up, and it's very often you would need to make sure you know a use for it, and the use is, of course, is a magnifying glass. The diagram is full scale. How far from the centre of the lens is the image formed? So if you measure that, just straighten it up for you there, and if you measured from the centre of the lens out, it is roughly just over 6 centimetres there, about 6.2 centimetres. It depends on your drawing. You should really use, if you can, try and use a mechanical pencil, i.e. the one that you can click the end and you get a really, really sharp pencil. And that will give you a very, very sharp point where your image is formed. The mark scheme actually will say that the answer is 6, but they'll allow plus or minus 0.2 centimetres there. So my answer is within the range, and it's probably just because I'm using quite a a blunt pen there to do my drawing or to finish my ray diagram. Before I go then, mark on the diagram where the eye should be placed to view the magnified image. So of course, if you're standing with a magnifying glass, you have it in front of your object, which is your page, and therefore you're looking from this side, and so therefore we need to be here. If you mark the eye there, and that will get you your mark here. What is a virtual image? It's one which cannot be captured on a screen. Now sometimes people will say it's one that rays of light do not pass through. Whereas a real image is one which rays of light do pass through.